So today we're going to be talking about rules for definite integrals. So there's 5 rules. The first rule is order of integration, 0 rule, constant multiple, sum and difference, and additivity. So our first definite integral rule is order of integration. So what this rule is basically saying is from the integral of a to b of function x, whatever that answer equals, whatever this function equals, is the same answer for when you're flipping your start point to end point, except it's going to be a negative. So in this example, we have the integral starting at 1 to 4, and this integral equals -2. So we want to find the integral of 4 to 1. So instead of starting at 1, we're starting at 4. And instead of ending at 4, we're ending at 1. We want to find this integral. So looking at this rule, we understand that it's going to follow the same number, so it's going to be 2, only it'll be positive instead of negative. Our second rule is the 0 rule. So what this rule is saying is that from the integral of a to a, our function x is going to equal 0. So since we're not moving our positions and we're staying at the same point, you're simply going to have your integral equal to 0. So if we look at this example from 4 to 4, our function x is going to equal 0. Our third rule is constant multiples. So in this rule, we have the integral from a to b of constant times the function of x, which equals the constant times the integral of a to b of function x. So in this rule, instead of keeping our constant here and solving it through, we take our constant outside of the integral and later multiply it again once our function x is solved. In this situation, we're going to take our 75 out, having our integral like so of the root of t, and we're going to solve. So the next rule is the sum and difference rule. In this rule, if we are ever given an integral of a to b of the function x plus or minus the function of g of x, instead of solving it like this, we can break it down as the integral of a to b of function x plus or minus the integral of a to b of g of x. In this example, we are given the integral of -2x to the power of -3 plus 20x to the power of -5. And rewrite it as the integral of -2x to the power of -3 dx. And since we're adding, plus the integral of 20x to the power of -5. We can also incorporate the constant multiple rule. So we're going to solve them separately. So we can now bring these two together and simply write x to the power of -2 minus 5x to the power of -4 plus our constant. So our last rule is additivity. So in this rule, if we're ever given an integral of a to b f of x plus the integral of b to c of function x, instead of doing it separately, such as this, since we have the same function, we can simply put them together and do the integral of a to c of function x. When we are given the integral of 7 to 8 of 75 plus the integral of 8 to 9 of 75, we can simply rewrite this problem as starting at 7 to 9 of 75 d of x. Follow the same rules where we pull out 75. So just for extra work, we're going to look at this practice problem. From the integral of 0 to 3 of x squared, we want to find the answer for this. So we know that our starting point is 0 and our end point is 3, and that x squared is a parabola. So we're just going to draw that quickly. And we're trying to find the area from 0 to 3. So we want this area.